Here we have a question based on beams. The second question. Two beams AC and CD of length 9 meters and 10 meters. Okay, AC and CD 9 meters and 10 meters is hinged at C. It is hinged at C. They are supported on the rollers at the left and the right ends. At the left and the right ends, that is at A and D. This is D. They are supported at the left and the right ends. A hinged support is provided at B. This is hinged support 7 meters from A as shown in the figure. It is 7 meters from A. Determine the reactions at the support B when a load of 700 newtons acts at a point 6 meters from D. Okay. Before solving this problem, the problem should be solved by using the concept called principle of virtual work. Okay. To solve this problem based on the principle of virtual work, wherever he asked to first, we should look at where he asked to find out the reaction. He asked to find out the reaction at the support B. Okay, he asked us to find the reaction at the support B. To find out the reaction at support B, there must be a virtual displacement. First point, we should note that wherever we have to find the reaction, at that point must be virtual displacement. Okay, to make this virtual displacement, the other reactions or the other virtual displacement must be 0. We have already know that the work done by the normal reactions will be 0. Here we have two supports. The two supports are roller supports. From the roller supports, we will be having normal reactions. From the normal reactions, the work done by the normal reactions will be 0. Okay. Now we can solve this. The work done by this must not be 0. It means the reaction at B should exist. The virtual reaction to exist, there must be a virtual displacement at B. Now, this is the beam which was given A and D. Okay. So now the two beams are hinged at C. Okay. They will be having motion like this. It means they will be at any angle. They can be at any angle having their motion. Okay. I am from this point C. Okay. I am assuming this point C. They took a virtual displacement like this. Okay. They took a virtual displacement like this. This is the point C. I am assuming it is as Y. Okay. Now at this point B, there will be a virtual displacement of X. I am assuming it as X1. And at another point E, there is a load which is, I am assuming distance of X2. Okay. This total distance which is of 9 plus 10, 19 meters. Okay. In the first case, I am already repeating that if we consider this B, there is no work done. Now the RB reaction will be 0. But wherever he asked to find, there must be a displacement. Now here, due to this RB, due to this reaction RB, we are having a displacement of X1. Due to this 700 newtons external load, we are having a displacement of X2. Now from the principle, this is at a distance of 7 meters from support A and this is at a distance of 6 meters from support D. Okay, and this total distance which is of 9 meters and this total distance which is of 10 meters. We already know that. From the principle of the triangles or the properties of the similar triangles, we can say that x1 by y equal to 7 by 9. That is x1 equal to 7y by 9. Okay. From this, x2 by y equal to 6 by 10. Therefore, x2 equal to 6y by 10. Okay. Is this clear? And next, we are asked to find the reaction at RB. Now, I am considering whatever the reactions. In the previous case, we are considered separately. Now, we are in a trend, we can solve directly. Okay. Now, whatever the reactions acting, here RA, suppose we are considering RA into, here the displacement took place is 0, RA into 0. Next, another end plus RD, here the displacement is 0, RD into 0. And next, we have to consider the reactions RB now. Now, plus RB into, here the displacement is X1. Okay, here the displacement is X1. Okay, First, the virtual work done by the support reactions. The virtual work done by the support reactions. Okay. Next, virtual work done by the external loads. Okay. Now, virtual work done by the loads. What is the load here acting? Only 700 newtons. Now 700 newtons is acting downwards. The displacement took place in the upward direction. Therefore, minus 700 into x2. From the principle, we can say that sum of the work done must be 0. Therefore, RB into x1 minus 700 into x2 must be equal to 0. Therefore, RB into x1 is nothing but 7y by 9, that is equal to 700 into x2. Here x2 is 6y by 10. Y get cancelled. Now RB equal to 700 into here 6 into 9 by 7 into 10. Now the final answer is RB equal to 540 newtons. Wherever you are asked to find, there must be a virtual displacement. Due to that virtual displacement, we get that reaction, that is RB. If we ask to find out the reaction at RA, there must be definitely a displacement. Okay, this is the way to solve the problem. Here we have a problem. A beam is supported and loaded as shown in the figure. Find the components of the reactions A and B. Here A is hinged and B is supported, normal support, that is nothing but a roller support. Here we will be having two reactions. Here we will be having only one reaction, that is normal reaction. And here in the x direction, we also observed that there is an horizontal reaction which is the 4000 newtons. Okay, this is the beam. Here the point A and this is the point B. Here we will be having two reactions. One is RAX in the x direction and the RAY in the y direction. Okay, and there is a roller support. At first, we already know that A is hinged. He asked to find the reactions at A and B. Okay, at first A is hinged, there will be no displacement. Therefore, the diagram will be like this. At this load, there will be like this. Therefore, the displacement took place is y, and here the displacement is x. Here is at a distance of 1 meter, and this total distance it is of 2 meters. Okay. Now, here we can simply say that RAX is equal to 4000 newtons. There is no any other force acting in the horizontal directions. There are only two forces, which is RAX and 4000 newtons, which are balanced. Okay, and next another force is RAY. Now, virtual work done by the support reactions. Now, virtual work done by the support reactions is RAX into 0 plus RB into y. Okay, now virtual work done by the external loads. Here the load is acting is 2500 in the distance of negative of x. Their summation must be 0 from the principle of virtual work. RB into y equal to 2500 into x. Here from the properties we can say that x by y equal to 1 by 3. X equal to y by 3. Okay. RB into y equal to 2500 into x is y by 3. Here y get cancelled. Now RB equal to 2500 divided by 3 newtons. This is the reaction of RB. Now to find RA, okay, we can also solve like this by summing over or by the from the equilibrium reactions. What we can say RBY RAY plus RB, what is the load acting? 2500 newtons. Okay, now I am requested to find RAY equal to 2500 newtons minus RB. I know RB 2500 minus 2500 by 3. Now let us find the RAY. The RAY reaction is 1250 newtons. This is the way to find it by using the principle of virtual work. We can also solve like this also. Here it is A and it is of B. They can take the displacement like this. Here it is also. At the load I am considering this point as C, therefore it is point C. BB dash is the displacement, CC dash is the displacement. It is of distance 1 meter. I am assuming this is as delta theta, therefore 1 into delta theta, and it is of 2 meters. 1 plus 2, 3 meters, therefore it is of 3 into delta theta. Okay, now 3 into delta theta. Now we can state that RB into 3 delta theta plus, now another reaction is C, minus 2500 into delta theta equal to 0. Directly from the principle of virtual work, summation must be 0. Therefore RB equal to 2500 into delta theta by 3 into delta theta. Delta theta gets cancelled. RB equal to 2500 by 3 newtons. Both are of same. We can solve or easier, which is easier, but some problems involves both. This problem is based on angular displacement, okay, and this is of linear displacement. Some problems involves both the cases, which will be easier. Here we have a problem. Two beams AE and BD, this of E, A and BD are supported on rollers B and C as shown in the figure, and determine the reactions at the rollers B and C using the method of virtual work. For these types of beams, we should separate them. Okay, first I am considering the beam AE, and next I will consider with the beam BD. Okay, now I will be considering with the beam. First I will consider with the beam AE. For this type of beam, here it is a roller support, having a roller support, and there is a at end there is a having a load of 500 newtons. Now this distance is of A. From this distance it is of 5 meters. From this 3 plus 2, 5 meters, and this total which is of 6 meters. From this we can conclude that this distance is 6 minus 5, 1 meter. Okay, however this beam is hinged. Okay, this beam is hinged, then the reactions will be, this beam is hinged, there will be two displacement. One is this part is C. Okay, this part is C. Now this will be having a reaction. Here I am considering this as E dash, and another which is due to the roller support. This is due to the 500 newtons load, point load, and this is due to load C dash, and is the point A, which is at a distance. We have already mentioned the distance in the upward direction. Okay, now work done by the loads, whatever the loads may be acting, total work done by the loads is RA into 0, because no work done by the reaction RA. Next, plus here the normal reaction acts in the upward direction, the displacement also took place in the upward direction. Okay, I am considering this is as X, this is as Y. Now plus RC into X. Here 500 newtons is acting downward direction, the displacement took place in the upward direction, therefore minus 500 into Y. Okay, that must be equal to 0 from the principle of virtual work. Now we can say that RC into X equal to 500 into Y. From the principle of what you can say properties of similar triangles, this is of 5 meters and this total distance is of 6 meters. Now X by 5 is equal to Y by 6. X equal to 5Y by 6. Now RC into 5Y by 6 is equal to 500 into Y. Y get cancelled. 5 into 100. Therefore RC equal to 600 newtons, which we got the reaction. One of the reaction which we got. Here two beams A and B are supported on rollers B and C. You mentioned that it's rollers. Okay, this is not the hinge, sorry. Please check it. Please go with the problem. Here it is the roller and that the rollers B and C. Sorry with this, you once correct it. Okay, now next with the we have considered one beam, we got the reaction RC 600 newtons. Next another beam, that is of BD. Here BD. Now here we can conclude that this D is hinged. Okay, here D is hinged and here B is roller supported, and this is the support which we got. This is C and the point is C, and there is a load of 1000 newtons acting. It is at a point of F. Okay, and the distances now we should mention. This is at a distance of 2 meters, and from this point to this point it is of 3 meters. It is at a distance of 2 meters and a distance of 3 meters and another distance of 3 meters. Now here B is roller support, D is hinged. He is given that D is hinged, therefore at the hinged there is no displacement. There will be displacement like this. Okay, at C, at B there will be displacement, and consider this as B dash, and at C we are having a displacement, assuming that C is C dash, and I also have another point F which is having a displacement of F dash. Now I am considering this as Y, this is as x1 and this is as x2. Now whatever the loads acting, the displacement took place by the particular load RB into Y. Okay, RB will be acting in the upward direction because here we are having a roller support. The normal reaction will be acting upward direction, both are in the same, therefore it indicates positive direction. RC is acting in the downward direction because the normal reaction always acts normal to the support, normal to the whatever the beam. Here it is downward direction, therefore minus RC into x1. Here also 1000 load acting downward direction, displacement took in the upward direction, minus 1000 into x2 equal to 0. Therefore RB into Y equal to, from this we can conclude that RC into x1 plus 1000 into x2. From the properties of the similar triangles we can state that here it is at a distance of x1 by Y equal to, x1 is at a distance of 3 plus 3 6 by, and this displacement 3 plus 3 6 7 8 6 by 8. Now x1 equal to 6y by 8, and here is having another one, that is x2 by y. X2 is at a distance of 3, y is at a distance of 8. Now for x2 equal to 3y by 8. Substitute this. RB into Y equal to, RC we are already find out that 600 into x1. x1 is 6y by 8 plus 1000 into x2. x2 is 3y by 8. By making common y, 600 into 6 by 8, by taking common 600 into 6 by 8 plus 1000 into 3 by 8, RB into Y. This Y get cancelled, therefore now RB reaction is 825 newtons. Repeat the problem. Whenever you have given so many beams, how many the beams may be? 1 or 2 or 3 or 4 greater than 2. For this, the first case we should separate the beams and find out the reactions in the beams. First you have chosen this beam, and next you have chosen this beam. In this way we have to solve the problem. First we should choose this beam, and whatever the reactions took place, here the A is hinged. At a hinged support there will be no displacement takes place, only at the normal reaction the displacement took place. In the next also there is no displacement at the hinged. Now we ask to find the reactions at the rollers at B and C. Now we got the rollers at B and C. This is the way to solve the problem. Here we have a problem. Two beams AB and CD are arranged and supported as shown in the figure. Find the reaction RE if a load of 1200 newtons acts as shown. Here we have one hinged at A and the other hinged at C, and two roller support. One is at whatever the point may be considered at D, and one is at E. Okay. Solve this problem. Take it as an assignment, and the answer for this is we ask to find RE. RD is equal to 750 newtons, and another one RE is equal to RD. D is nothing but this is D for roller support RD, and RE is 937.5 newtons. Take it as an assignment. For solution of this problem, if you need a solution of this problem, try to watch the next lecture, which is of part 4 or part 5. For solution to this, try to check the next lecture. However, this is also can be solved by the same method. Separate these two beams, whatever the reactions acting, show on them, draw the virtual diagram, show the virtual displacement, then algebraic sum must be 0. From the principle of virtual work, we can get the reactions. Try to watch the next lecture and subscribe to our channel.